All right, today we're going to be looking at chapter 5.3, Independence and Multiplication Rule. So this time I'm not going to spend a lot of time going through the textbook, but I will ask you to go ahead and read, go through and look at all the definitions. There's a lot of nice examples that they provide for you so you can get a better understanding. But for the sake of this intro video, I just want to give you a mini lecture and a micro understanding of what you're going to be seeing in this section. I'll try to keep it about 5 minutes. So we're going to be looking at independent events. We're going to be looking at how to use the multiplication rule for independent events and compute at least probability. So these are like the main ideas. And so let me give you a small example of what those look like. So let's say that I have a coin and I'm going to flip a coin 2 times. This is one example that you might see in the textbook. I'll just say twice. Okay, so if I flip a coin twice, there are several different things that can happen, namely 4. Both coins can land on heads. The first one can land on heads and the second one can land on tails. Consequently, the first one can land on tails and then the second one land on heads, or they can both land on tails. Okay, so in this experiment there are 4 outcomes. So when we talk about probability, usually we assign each outcome the same value. So there's 1 out of 4 for any one of these outcomes happening. However, we get a little bit more detailed and we might make a probability distribution. So let's say we want to count the number of heads that occur. So if I look at this, there are 3 things that can happen. I can get both tails, which would mean I would get 0 heads. I could get 1, and there's 2 ways that can happen. It could be on the first flip or the second flip. So 1 head on the 2 flips is possible. Or I can get 2 heads. They both came up heads on the flip. Okay. Then each of these will have a probability. So let's say the probability that I get 0 heads when I flip a coin twice. There's 1 outcome out of 4. So that probability would be 1 out of 4. I could look at the probability that I get exactly 1 head when I flip a coin twice. Probability of 1. There's 2 of them out of 4, so we can say 2 out of 4. Or we can reduce that and say 1/2. Okay, that's going to be the better option, 1/2. And then the third option is I can get 2 heads when I flip a coin twice. So if that's the case, probability that we get 2 heads is again 1 out of 4. We're going to talk about independence. Independent means basically one does not affect the other. So when you flip a coin, the outcome of the first flip does not dictate the second flip. You still have a 50% chance. So how is, if you want to get a better understanding of how when you get 2 heads it's 1/4, when you flip a coin the first time it's 1/2. And if you know the events are independent, which means one doesn't affect the other, you multiply them to get the probability of both of those events happening. So the first flip is 1/2, the second flip is 1/2 because there's 1 out of 2 of coming up heads. You multiply straight across and we get 1. 1 times 1 is 1, 2 times 2 is 4. So we get 1 out of 4. Independent means one does not affect the other. If you want to see what that looks like in the Venn diagram, independent events can overlap, which means I can flip the coin twice and get 2 heads in the middle. But it also, to find that middle, I would multiply to get that intersection. So independent events will look like this. We're also going to talk about mutually exclusive events. So mutually exclusive events mean these cannot happen at the same time. I'll say can't happen together. So if I looked at a Venn diagram of mutually exclusive, that would mean this circle here does not overlap with this circle here. So we can talk about like a deck of cards, and let's say this is a red card, and let's say that this is a spade. So the chance of me drawing a red card that is also a spade is impossible, because spades are black and the red cards will be hearts and diamonds. So if you have two events that cannot happen at the same time, they would be mutually exclusive. If you have two events that one does not affect the other, they're independent. Independent does not mean mutually exclusive. These are not the same thing, as you can see from the diagrams. Here I can get two heads at the same time, even though one does not affect the other. So this is going to be the general idea of this section. You're going to want to figure out if events are independent. Sometimes they'll tell you, sometimes you got to figure it out. They'll also throw in mutually exclusive, and then you'll be given some probabilities. And one thing you want to be able to do is compute probability distributions and at least probability. So the last part that I'm going to talk about is at least probability, using this example up here. So let's say that I'm using these numbers. One of the properties of probability is that if you add up all the different outcomes, so I'm dealing with this flipping coin twice and getting the number of heads that show up, it can either be 0, 1, or 2. When I add up all these numbers, that equals to 100% or 1. So up here, we did the math. We had 1 over 4, 2 over 4, and 1 over 4, or 1/2. I'll just write it in fourths. So we got 1 over 4 plus 2 over 4 plus 1 over 4. We're getting two of them. When I add that up, 1, since they all have the same denominator, 1 plus 2 is 3, 3 plus 1 is 4, I get 4 over 4, which is equal to 1. So this is just the general rule. One of the properties of probability is that all of your outcomes, when you add them together, equal 1. When we talk about at least probability, so if I say probability, let's just say, I'm going to say X is at least 1 head. So I want 1 or more heads. I don't know why I put a number sign. 1 or more heads when I flip a coin twice. So 1 or more, what that means is the probability of 1 plus probability of 2, and it could be so on if there was a different example that had more options, but 1 plus 2, so forth and so on until you get to the last one. Well, in our example, it's just 2. Most of the time, we might not know all of these probabilities. So the way we're going to compute at least probabilities is going to be by using this scenario here. Usually, we will be able to compute 0 of them. So knowing that I repeated this experiment twice, I know that 1, which is the total, we're going to take away the probability that we get none of them. So if you think about this like an algebra problem, which I'll set up here. So notice we have probability of 0 plus the probability of 1 plus the probability of 2, that equals 1. So if I do some algebra and I subtract the probability of 0 away, and why am I getting rid of that? Because this problem wanted at least 1, so that's 1 or more, so that would be these two here. We want 1 or more. So we're going to subtract that 0 off from both sides, and that's going to give me the probability that I get 1 or more is equal to 1 minus the probability that I get none. And this is going to be how we compute at least. Just the general rule. It might not look exactly like this every time, but this is just in general. this is the part we're going to focus on. When you know events are independent and you know how many times you repeated that experiment, the probability of 0, which we already computed up here, was 1/4. But if you had to do it in a problem and you're told independent and the probability, we're going to say 1 minus whatever the probability of that experiment is, just flipping it once. And however many times we flip that coin, we're going to raise it to that power, so to the second power. That's the same thing as 1/2 times 1/2, because I knew though the flips were independent, so 1/2 times 1/2 gives me 1/4. Same thing as squaring it. That's squaring the top, which is 1, and the bottom, square that, you get 4. So this will be equal to 1 minus 1/4, and this will give me 3/4. 3/4 is the same thing that you would get if we added the 1 and the 2 together. So again, sometimes we won't know these. If we do know them, it's easy just to kind of add those two numbers. However, when you got like 8, 9, 10 different options, it's easier to just take your total, which is 1, subtract the one that can't happen, and you're subtracting one thing versus having to add up 7, 8, 9, 10 different things. So overall, in this section, we're going to be looking at the probability of some event. We're going to try to determine if it's independent. If it's independent, we can find the probability that those two events happen at the same time by multiplying those two probabilities together. You do need to understand the difference between mutually exclusive and independent. Here's a diagram to kind of see the difference. Independent means that they don't affect each other. They can happen at the same time. Mutually exclusive, they cannot happen at the same time. And then this is just a general model of what we will be doing when we compute at least probability. Usually it's at least 1 in this section, and at least 1 means 1 minus the probability that none of them happen. And the way you do that is going to take your probability, raise it to the number of times you're going to do that experiment, and subtract that from 1, and that will give you your at least probability. So anyway, I hope this helps as a general overview. At this point, we're going to jump over to my math lab and start working some problems.